Hey everyone, in this video I will go through named entity recognition or NER, a very popular topic and very important topic, and implementation of these with the super popular spaCy library. And for the dataset, I'll be using these all the news dataset from Kaggle. So this has around 50,000 rows of data saved in a CSV file with the various articles written by various newspapers. And the goal of this video is to first implement some of the basic functionalities of spaCy library to extract named entities from a given document, and then to improvise that extraction of named entities further to extract more information out of those documents. For example, whether a particular named entity is acting as a subject or an object, and also whether a particular named entity is being occurring with another named entity, things like that. So here I am in my VS Code. So initially I'm just importing pandas, and also I have downloaded these Kaggle dataset in my local machine. So you can just go to this link, kaggle.com dataset snack pack all the news. I will definitely give the link of this in the description, and just click on the download, and it will download these around 670 MB of data, and there are 3 CSV files. And we can see that these are the column heading. I have ID, title, publication, author. If I move further, the last column is the important one, which is article content. So for this particular video, this project, I'm only concerned about this column because I'm going to apply my NER techniques on the text content of this column. So I'm just defining a root directory and then doing a pd.readcsv to just read the article.csv. And then if I run df.shape, we can see we have 50,000 rows and 10 column. And with df.head, I can see the actual data structure of the CSV file. So I have title, publication. This is important. I need publication column to conditionally fetch articles written by only a specific publication. And then author, date, year, month, URL, content. Yeah, this is the important column. Okay, now so what I'm doing is I'm just checking how many unique publications are there in this dataset, and we can see there are only 4 unique publications for 50,000 rows: New York Times, Breitbart, CNN, Business Insider, Atlantic. Sorry, 5 of them. And in the next cell, what I'm doing is I am conditionally fetching this condition is for only for publication where this is in New York Times. So I'm only fetching where the publication is New York Times, and then also I'm not fetching the entire 50,000 rows, because then in that case each of my code execution will take a bit of time for applying various spaCy techniques. So I'm just extracting 100 rows. Yeah, and then I'm checking content df.shape. That's obviously will give me 100 because I've extracted 100 rows. Remember, again, there are 50,000 rows in these CSV. And now quickly check my content df.head. Yep, so now I have only the content, because in the previous cell with this line, that is df.loc condition, and then getting everything with this slice notation, I am just extracting the content column, not any other column. That's why in this I can see only the content column. And I also want to check the actual articles, actual content of those articles. So let's quickly do that. Content df. Let's print only print only two of them, slice 2, because each of these is quite long. Yeah, so we can see these are long articles, each one of them. I have a large, quite long output just for printing the top two. Yeah, so now what I'm going to do is to select a random text from these articles, just a single sentence maybe, and pass it to spaCy and print the tokens that spaCy prints after reading through or going through that particular sentence. But before doing that, quickly go over the official documentation of spaCy, because that is needed to understand what spaCy does after it is passed any text. So when you call NLP on, so I'm reading on the pipeline part. So pipeline basically gives the steps or the various phases of the pipeline that spaCy goes through before it returns you the token on any random text. When you, so what it says is, when you call NLP on a text, spaCy first tokenizes the text to produce a doc object. Super important, because from these doc object all my various information will be coming forward to me. So the doc is then processed in several different steps. This is also referred to as the processing pipeline. The pipeline used by the trained pipelines typically includes a tagger, a lematizer, a parser, and an entity recognizer. Each pipeline component returns the processed doc, which is then passed on to the next component. Okay, so sorry. So that's what I'm going to do now. I will pass this text to NLP, that is to spaCy, and then I will get back this doc object after that text is passed through the various parts within the pipeline. And yeah, so let's do that. Import. And now the most important part, NLP. NLP is my, I have to load a few things from spaCy. So those are actually the language models that spaCy has. So let me quickly write it and then I'll look into the documentation. spaCy.load. And this is absolutely standard boilerplate thing that you have to do for all of your spaCy project. So I'm just loading NCore web and small. I'm loading the small so that my code will run faster. But in most of the real cases, you want to load the large one, that is LG. So let's quickly see what they are actually. So here I am in the spaCy documentation. So these that I just loaded, this is NCore web SM. This is a trained pipelines for English model. And this is only 12 MB. So I could load NCore Web MD, which is slightly larger, and that is 31 MB. And this has got 685K keys, 20,000 unique vectors, 300 dimension. Let's see what was that for my smaller one. So okay, this one says 0 key, 0 unique vector, 0 dimension. I really don't know why they're all saying 0. Let me check it. Let me check it later. All right, so that's my MD, and I could even load even the biggest one, which is NCore Web LG. This is 382 MB file size. And this has got 685,000 keys, 343,000 unique vectors, and 300 dimension. I also have NCore Web TRF. Okay, so yeah, that's it. Now, so when you run it for the first time, this will take a couple of minutes to load it. That is it. This particular 12 MB file will get downloaded from spaCy, and yeah, it may take a minute or so. And now let's take my text from any of these. So what I'm going to do, I'm just going to take, maybe he would not tell the police that he had learned I'm just taking a random text from here. And then I am going to define a doc object, which will be my NLP. And NLP is this NLP. And within this, I will pass this text. And then I'm going to print all the tokens that this doc object will give me. So for token doc, LEMMA, and of course you can get all these attributes, that is .text, .lemma underscore etc. in the documentation. So I have token dot position, token dot tag, token dot depth, token dot shape, token dot is alpha, and further I have token dot is top. Okay, let's just run this cell. Why does it say outputs are collapsed? Let's zoom out a little bit. Still output is collapsed. Okay, let's just open it. Yeah. Oh yeah. So right. Yeah. So this is all these tokens that I got. So this first one is text. So this is the original text. So I got token dot text here, then token dot lemma, token dot position, token dot tag, dep, etc. All these things. So this sentence was not a very special one. I mean, in this sentence there's not too many parts of speech component, so we don't see that's why we are seeing not here. But this is just for an example that how the tokenization work in spaCy, and this is what we will be working with in the entire named entity recognition. And now I'm going to represent the named entities in a particular Python dict format. So what I want to do is represent my named entities like this. So for example, GPE is the named entity type, and in my dataset I have within the GPE Washington, number of times it occurred 1, Obama number of times 1, the District of Columbia Circuit 1, New York City 3, etc., something like this. So again, for the next type NOR-P, I will have the number of times various entities occurred within NOR-P and the corresponding count. So let's build a function for doing that. And also this function should return me the process docs. That is when I load these all news dataset. I have loaded 100 of them. So this function should return me the NLP converted docs as a doc object from spaCy. So because I'm going to use that process doc many times further down the notebook for doing other processing. So this function is like a root function which will serve me or return the process doc. So just start writing the function. Let's name it return entities, TIES, and process docs. My naming convention is becoming longer, but I'm just trying to be explicit about what a particular function is doing. initialize this to be an empty dict, and that's an empty list. Now I have to start a loop through the data frame. Now here is where I am extracting the doc object from each item. So as we did before, I pass the item inside the NLP function. So item. And what is our NLP? We have already defined the NLP before, which is here. So NLP is just NLP equal to spaCy.load and ncore web sm. Process docs dot append, sorry, doc, that is all. So this is this becomes a list which will have all the doc object of each of the doc, and this is also the variable that I'm going to return at the end of the function, and which will be used many times throughout this notebook. That is this particular variable process docs. Now I have to start another loop, the inner iteration or inner loop, to extract this information, these data, that is under each entity type. I need to extract the individual entities and the corresponding counts of them. This will give me the actual entity text. Maybe, for example, what did I have here? Like Washington. And now entity type. That will be str label underscore. This will become the type. For example, Washington comes under GPE. So like that. Okay. Now declare another dict to hold my current entities. Now, if the type say, for example, if the type say GPE already exists, that is, if a particular type is already exist in named entities, then just get it or extract it. So I have to run an if function, entity type. What did happen? Entity type named entities dot keys entity type. And then increase the count of the or the counter number of the actual entity text. For example, here what I have Washington, that is just one. If I had Republicans, that will have many counts of the Republicans text, so I have to increase this count after I find it. Sorry, here the comment will be Actually, it will be, yeah, current entities, entity text equal to current entities dot get entity text 0 plus 1, and then make these updated inner dict to be the new inner dict for the final named entities, that after increasing the count I have to modify the inner dict. So now named entities, entity text, sorry, current ends, and finally return these named entities and also process docs. Process docs, yeah. Let's run this function to check if it is working. So what I'm doing is return entities and process doc. To that I will pass my content df, which we have already defined, and this will return me the named entities tr and also process docs. And after I run this cell, it may take a couple of minutes to run because it's going through a lot of documents, all those 100 articles that I have extracted in my content df, and inside it, it's doing all these processes. Okay, it took just 14.7 seconds. All right, now just print my named entities. Just to check if it is working. Yeah, it's working. We can see this is the dict format that I wanted. Republicans, actually not, because my inside dict and outside dict, it's saying the same. This outside should be the entity type. For example, for Washington, it should be GPE. Okay, let's fix my code. And of course, I think I found the error. Here, when I was updating the named entities, here I was updating entity text, but it should be entity type. And that's when that's when these outer key will be the entity type, because right now it was just taking the entity text, but the entity text should be coming in the inner dict. Okay, let's run it again. And now run the next cell, named entities. Yes, now I got the correct way that I was expecting. So my entity type is on the outside and each entity text is inside. All right, now we can see that let's check the length of these. Let's also check the process docs, but process docs will actually print too many of them. So just check the length. Process docs, yes, 100. If I print only the process docs, it will be a huge printout, because it will print each of the articles and 100 articles together. So and also another thing I wanted to do is this particular way that named entity is getting represented, I want to make the structure a little bit better. That is, currently all are kind of jumbled up. So let's express this in a little bit better with another function. So this is what I want to achieve here. That is, in this code, you print out the type of named entities, and for each type, you extract all the entities assigned with this type in the dictionary, sorted by their frequency in descending order. And I'm going to print and I'm going to show only the top 10 counts under each entity type. Print top 10. What I'm going to do, sorted keys. Let's put a quick comment here. Sorted key is equal to sorry, I have to define entities which will be named keys. Okay, and then I'm going to sort these entities. Reverse equal to true. Taking the top 10. Sorry. Get item. ENTITIS dot get item is more than 1. Only then I print plus item plus entities dot get item. Cool. Now I do print top 10 named entities. Where is, yep. Named keys is not defined. Yep, that will be just key. Okay, I'm getting United States, China, Russia, but this is slightly off my requirement. I wanted the type to come at the top. Let's figure out where did I go wrong. Actually, everything looks right. I only need to print the keys. So that right now I only have a single print statement, which is printing the actual entities, but I also need to print the entity type. So that would be before my here print key. So okay, now let's run it. Yeah, now it is showing how I wanted to show. So at the top, it's coming the entity type, and then it's showing the various entities and their count. And I'm only printing 10 of them. Okay. And also, if I just wanted to see the named entity keys, so we can quickly see named entities dot keys. Yeah, so these are all my his, GP, norm, person, org, etc. All right, now one of the more important parts of this video, which is looking at some practical application of named entity recognition in the industry. So one of the important application of NER is that extraction of subject or an object from a given sentence. Suppose you have a sentence and your named entity of interest is a multi-word expression, which is the New York Times in this case, because we have many articles which are written by New York Times, and it is a multi-word phrase, and that's my named entity. And also suppose that the full sentence is that something like this, that the New York Times wrote about Apple company. And here your goal is to identify whether the New York Times is one of the participants of the main action, that is, whether New York Times actually wrote in this sentence, that is, whether New York Times is a subject, or the New York Times is an object, that is, whether an action was performed on New York Times. So from these above statement, that is the New York Times wrote about Apple, we can see that the New York Times as a whole is the subject. It is the entity that performed the action of writing. And now the problem is, how can you extract the whole expression, the New York Times, by applying named entity recognition? And why it's a problem is because, in general, linguistic analysis applies to individual words rather than the whole expression. So technically, in this statement, the New York Times, this Times will be our subject as extracted by a normal NER mechanism. And that's because this Times is directly dependent on the main verb wrote. And this is the overall solution approach that we will take to solve this problem of finding the New York Times, this whole phrase, multi-word phrase, as the subject of the total statement. And so this is the whole statement. The New York Times wrote about Apple, and we have to find the New York Times only as our subject. So the first step of the solution is you first identify the indexes of the words covered by the expression in the sentence. For the New York Times, these are 0, 1, 2, 3 in our case. Next, that is, in the second half of the task, you check if a word with any of these indexes plays a role of the subject or an object in the sentence. And in our case, that is, our whole expression is New York Times. In our case, we see that indeed the word that is subject in the sentence has the index of 3, because this Times, which is directly dependent on the verb, the main verb in the whole statement, which is wrote. So Times, this particular word in our case is the main subject. Now we see, so therefore, because the Times is the main subject, now finally you can return the whole named entity, that is the whole the New York Times, as the subject of the main action in the sentence. And now I will implement step-by-step algorithm with two methods to follow this approach. First, the function to get my document span, entity span. So given here, this method will be given a document and an entity, and it needs to find the span of the entity in the document. Define an empty list as my indexes that will hold the indexes, and now looping through the document ends. So for end in is equal to the given entity, which is coming from the argument. And only if this condition is satisfied, then I need to update the indexes list. So I need to update by the actual indexes. So what I do is I loop I loop over, not looping, traverse through a range of int. So I get a start position from the end, but from spaCy. So I can do end dot strd, and also I can do end dot end. Yep. Append I. That is all. Okay. Now let's check this method if it's working. So these are just our whole sentence and the entity that I'm looking for. And as we discussed above, that this method should, in this case, for these two examples, this method should return me 0, 1, 2, 3, because the New York Times, this entity appears in the sentence in index as 0, 1, 2, 3. These are the 4 words, and the indexes are 0, 1, 2, 3. So let's first convert it to document object. So I do doc equal to NLP sentences. Okay, and then I just invoke this method. That is all. Doc, and entity is entity. Yes, I got 0, 1, 2, 3 as my span of the entity in the document. All right, now the next step. And the next step is about finding or identifying whether a named entity in question plays a role of a subject or an object. That is, we have two participants for two actions. The actions are like the subject actually performs the action, and the object is the one on which an action is performed. For example, in this case, the New York Times is the subject because that performs the action of writing. Okay, so before so I need to build a long method to move through various parts of speech tagging that spaCy gives you given a sentence, and then checking accordingly. But before that, I just want to show you some basic way to get those root or preposition or the nominal subject from a document in spaCy. So what I'm going to do, let's say I already have the sentences and entity defined, so I'm just running a simple loop for sentence in sentences. I'm just doing one thing, doc. Actually, my doc is also defined already, but anyway, I'm going to define it again. NLP equal to sentence. Okay, and so this NLP sentence will give me the document object after spaCy parses the sentence. So now I cannot get directly the preposition, noun, etc. from this sentence. I have to parse it through spaCy. Then spaCy will return me the document, this doc object, and that will have various information, extra information. So in this case, I'm just going to check the DEP underscore thing, which will give you the N subject, that is nominal subject, root, preposition, etc. So the next step is for token in doc, because this doc will have various token. Print token dot DEP underscore. All right, so these are the kind of things I get. And if you are thinking about from where did I get this dep underscore, let's quickly go to their documentation. So I'm looking at spaCy's official documentation under the parts of speech tagging section, POS tagging, under linguistic feature, POS tagging. So here they say very specifically and very clearly, spaCy has a very good documentation indeed. So what they say is processing raw text intelligently is difficult. Most words are rare, and it's common for words that look completely different to mean almost the same thing. The same words in a different order can mean something completely different. Even splitting text into useful word-like units can be difficult in many languages. While it's possible to solve some problems starting from only the raw characteristics, is usually better to use linguistic knowledge to add useful information. That's exactly what spaCy is designed to do. You put in raw text and get back a doc object that comes with a variety of annotations. Yeah, so this is the most important part, and that's what we did. We put in a raw text and got back a doc object, and that will have all these parts of speech tagging. So after tokenization, spaCy can parse and tag a given doc. This is where the trained pipeline and its statistical model come in, which enables spaCy to make predictions of which tag or label most likely applies in this context. Linguistic annotations are available as token attributes. Like many NLP libraries, spaCy encodes all strings to hash values to reduce memory usage and improve efficiency. So to get the readable string representation of an attribute, you need to add an underscore to its name. That's why I did this. That is dep underscore. So this is a very exhaustive example. They are producing a doc object by giving Apple is looking at buying UK startup for $1 billion, and then spaCy is printing all these extra information: token.text, token.lemma underscore, token.pose, position underscore, all these things. And then the output, this table shows the meaning of various tags and outputs, etc. All right, so that's how we got this. Now coming back to our work, now I am going to build the long method called, so I'm going to name this method as calculate entity subject object, because this method will give me will print the subject tokens very much. So let's start diff calculate entity subject object. It will take a document and will take entity and indexes, and indexes is what we will get by executing this method calculate entity span, which will give me the range of indexes. And before moving ahead, I'm just taking another look at this definition because I mainly need to use this POS and DEP. So this POS will give me the parts of speech tagging like proper noun, verb, adverb, etc., noun. And DEP will give me these things, whether it's a nominal subject or root, then D object, prep, etc. All right. Defining and declaring some variables to their initial state. And now looping through the document for token in document. First, we need to identify the main verb expressing the main action in the sentence. And to extract the relationship, we have to find the the root of the sentence, which is also the verb of the sentence. So let's put a comment to. So what I'm going to do, I need to extract from token.pos underscore. POS has verb, yep. Only if the condition is satisfied, then initialize the indexes for the subject and the object related to the main verb. Subject index will be -1. Similarly, object index will be -1. And now I'm going to do few things, which is store the main verb itself, that is the token.text content in the action variable. spaCy uses the terms head and child to describe the words connected by a single arc in the dependency tree. And I'm going to use these child and children terminology quite a few times in this method. The term dep here, that is dep, is used for the arc label, which describes the types of syntactic relationship that connects the child to the head. As with other attributes of spaCy, the value of .dep is a hash value, and you can get the string with a dep by adding an underscore. That's why I'm adding dep underscore. So now store the main verb variable action equal to my children will be children. Oops, what happened? Child in token.children. And now loop through this children variable. In children. So here now I'm going to find the subject via the NSUBJ, that is nominal subject variable, which actually define the relationship and also store these nsubj as participant 1. Find the subject via nsubj relationship and store it as participant 1. And yeah, so if child 1 dot quickly take a look at the yeah, dep has nsubj. J index will be integer of child 1 dot I. And now if there is a preposition attached to the verb, for example, in our case, write about, then so our full sentence is the New York Times wrote about Apple. So these wrote about this kind of things. So if there is a preposition attached to the verb, then you need to search for the indirect object as the second participant. Let's put that in comments to make it clear here. If child1 .bp prep participant 2 will be equal to child 1 dot child 1 dot children. Am I doing it right? Yep, looks like so. I have to just get all the elements of child 1 dot children. So child for child in child 1 dot chi ldren. And now if such an object is a noun, that is, we found indirect object. If such an object is noun or a proper noun, you need to store it as participant 2 and its index as object index. So I have let's put that in comment. Okay, no, not here. I got child 1 children, and now I need to loop through it for child 2 and child 1 children. Yeah, here I need to find for noun or proper noun. So I'm going to do, okay, so where do I get noun and proper noun? Let's look at the documentation again. Under the position POS, I got proper noun, I got noun. Yep. So if child 2 dot POS or child 2 dot POS PROPN, then participant 2 will be equal to child 2 dot text. Similarly, object index need to be the index of child 2. All right, looks like I should be out of this for loop now. So now if at this position, at this point, I got both participant 1, where is the participant 1? Here, participant 1 and participant 2 defined. So basically, given that at this point, both the participant 1 and 2 of the main actions have been identified and their indexes are included in the indexes of the words covered by the entity. So now you add the action with 2 participants to the list of actions. Put that as a comment here for my proper step-by-step moving forward. It's quite a bit long function that it's becoming, so putting proper comment is extremely important. So now if I need to check that participant 2 is not an empty string, because I need to make sure that both are properly defined before adding them to the actions. If not, participant 2 indexes, and remember these indexes is what we got as part of the arguments, and this is coming from our previous function, which is calculate entity span, which will give me a list like this of all the indexes of the entity. So if subj index in indexes, then append, and what I append is entity plus empty string plus action plus empty single space string plus child child1 dot text plus a single space plus participant 2. Okay, and else if object index equal to sorry, object indexes in indexes, then what I need to do, I add actions dot append participant 1 plus space plus action plus space plus child dot text plus space child 1, and the last one is entity. Okay, now note that all these two loops are working under this condition if child1 dot deep underscore is preposition, and otherwise, that is if there is no preposition attached to the verb, then participant 2 is a direct object of the main verb, which can be identified via the d object relationship. So I need to come out of and do the next else condition of these this condition as well. So this is, yeah, so otherwise if there is no preposition, then we need to do if child1 dot deep underscore it's a direct object, so dobj, and child1 dot pose noun, or child1 dot pose propn proper noun, then participant 2 equal to child1 dot text child1 dot text sorry child1 and object index equal to child1 dot I, wrap that inside an int, and in this case you apply the same strategy as above, which is adding the action with two participants to the list of actions. So I think okay, let's just type it out. Subject, so what was the situation here? Sorry, if not participant 2, then if subj index in indexes, or elif obj indexes obj in indexes. Okay, so I'm going to need the same kind of things here as well. Let's just copy it. Oops, sorry. Yeah. I think I messed up. 1 second. Yeah. Now I only need to change the actions that append part. Uh, First one will be entity plus single space action plus participant 2, and the second one will be participant 1 plus action plus entity. Yeah, participant 1 plus action plus entity. All right, I'm coming towards the end of this method. Let me zoom out and see my whole to check my proper indentation. Yeah. So finally, now if the final list of the action is not empty, then just print out the sentence and all actions together with the participants. That's what I'm going to do now. And my for a long method in Python in problem is making sure I am properly indented. So go one step further here. Okay. I'm just checking the actions length is not 0. Actions. Then print format, first new line and CE sentence will be equal to my document, and then for item in actions, just print the item. That is all. Okay. Yeah, this should be all right. And now I need to check that this method is indeed working. So I'm going to use this method on my initial data of entity and sentence. What is that? Yeah, entity is this and sentence is this. And let's check that it's working. For sentence in sentences, indexes will be equal to calculate entity span. Enter and tab is not working properly in my VS Code. Calculate entity span and pass to that doc and entity, and then finally I need to invoke these calc entity calc entity subject object, and to that you pass doc entity and the span of indexes. Awesome. So here the sentence is the New York Times wrote about Apple, and I'm also printing this because it's kind of the summary, but actually the purpose is to capture the subject and object from a given sentence. That seems to be working fine, but we will actually see the proper application and implementation of this method when I apply this on the entire data set in a minute. And now note that this function calc entity subject object is it's doing quite a few things. So it's rather CPU intensive, not too much, but not too less as well. So One way to reduce the computation in here is that if you are only interested in a particular entity, it doesn't make sense to waste these functions efforts on the text and sentences that don't mention that particular entity that you need. Hence, let's first extract all sentences that mention the entity in question that you are interested in from processed docs. And for that, I need another function. And let's name this function return docs of given end type. And it will take argument as process docs entity and end type. Now, if the way that this function will work is that if a sentence contains input entity, for example, Apple, of a specified entity type, for example, org, among its named entities, you add that sentence to the output sentence. Otherwise, you do not add. And ultimately return all the sentences which satisfies that condition. So yeah, so let's first define a list which will be returned sentences processed doc. What's happening when I press tab? It's going to the next. Yeah. And only consider sentences that contain the input entity of the specified type among all its return entity. Sorry, I was searching for iPad Pro. Yeah, put the comment only consider sentences that contain the input entity of the specified type. T dot text for int type, sorry, int dot label underscore equal to and type. Only then output sentences dot append sentence. Okay. Oh, it will be not, sorry, I need to have let's just cut it. I need to have another looping clause for doc in process doc for sentence in doc dot sends, and then inside it goes my condition. Yeah, that's all. And then just return output sentences. Okay, check this method, it's working properly. Let's define entity equal to Apple and sentences for the case of Apple will be return docs given in type. We have defined process docs at the very top of this notebook. Entity is my Apple and entity type, let's put org, and then print int Tenses. Okay. All right. So that's my all the sentences which has got apple with an org n type inside it. So yeah, so that's the sentences I got. So these sentences actually matches this condition, and so thereby now I'm going to apply this long method of calc entity subject object on these selected sentences. Thereby I'm going to reduce the calculation intensity quite a bit. And now finally I am going to make use of all these previous functions to get the subject and object, and also kind of summarize the sentences. And yeah, so let's start just doing that. For sentence, so notice that now I am only looping through these end sentences. This is what we got from the previous cell, that is, which satisfies the condition that the sentences should contain the apple as the entity name, and entity type should be org. So I'm not looping through the entire corpus of articles. I'm only looping through the corpus which has this condition satisfied, thereby reducing my calculations quite a bit. Entity span, so let's run this cell. Local variable subj index referenced before assignment. Let's fix this. So I go to my this method where it's saying that this local variable subj index is used before assignment, is referenced before assignment. Okay, so I must have I'm using it before assignment, but I have already assigned it at the top. Oh yeah, I see here it's a spelling mistake. It would be subj. Yeah, now it should be all right. Yeah, now this line just ran fine, and here we see the result. So at the top is the original sentence. Apple, complying with what it said was a request from Chinese authorities, removed news apps created by the New York Times from its app store in China late last month. And this is the original sentence, and this is what my code extracted. Apple removed apps. This is the main point, the main action, and the participant as well. That is the participant, that is the actual subject who executed this action. So this seems to be correct. Let's look at here. Here the original sentence is Apple removed both the and apps from the App Store in China on December 23 from the store. Yeah, Apple removed on December. Okay, this also seems correct. And okay, so this is just another one. And remember, I'm getting only 3 results because of at the very top for my process docs, I extracted only 100 of them. Yeah, so there are 50,000 rows in the articles in this CSV file, articles 1.csv, but I have only taken for this exercise 100. So if I do it with entire 50,000, I will get much better result. Okay, so this result was with a single word entity name, which was Apple. Now I'm going to change my entity name to a multi-word phrase. So I'm going to select the New York Times as my entity name and see the result. Here is my code. Entity, I am now changing to New York Times, and then I am creating end sentences which satisfies the condition that the corpus should have these as the entity and the type should be org, and running the same code here again, that is looping through sentences, looping through end sentences, and invoking calc entity type subject object. Now let's run this. Okay, I got one result. So here entire sentence is during negotiation with Mr. Corzine last year, the commission also strengthened aspects of the deal after some of the agency's commissioners questioned it, the New York Times reported at the time. And look at this. This is my extracted sentence, extracted part of the sentence, which is the New York Times reported at time. And that looks to me correct. It extracted the verb, it extracted the main participant. All right, so that was the purpose of the code. Now I'm going to apply some. So that was by this point I am done with the this entire exercise, which was to extract the verb, object, subject from a sentence. With the three methods that I built till now. So this is where it ends, and now in my next quick section I'm just going to apply some visualization with the very important and very popular module of spaCy called displacy. Yeah, apply visualization with displacy. And here again I need to first import displacy. I'm then giving a random text, creating the doc object here, and then I'm just displacy.render, give the doc style ent. Okay, let's run this. Awesome. We can see that each of these are named entities, and also it shows the kind of entity it is, that is the entity type. So the last week, that's a date. Democratic is NORP. Senate is selected to be ORG. Apple, GM, Facebook, all are selected as ORG. Awesome. That's looking beautiful. And then, so that was on a random text. Now I'm going to do the same, that is using displacy on our corpus, our news dataset. So visualize entity type in sentences containing the specified entity and entity type. So let me first define a method. Where did that go? Yeah. Visualize given ent and type. Visualize given ent type, process doc entity ent type for processed. Again, my tab is not working. Processed. Oops, what's happening? Let me quickly check. Process std. Yeah, when I press the down arrow, it's not selecting. Okay, let me just std processed docs. All right, for doc in process docs, it should be docs here. So the condition that I'm going to select, that entity should be this entity that I had mentioned here, and the entity type also should match. So if entity in ent.text for ent in sentence dot ents, if ent dot label is equal to ent type. Okay, only then show displacy. Sentence style equal to ent. Sorry, my method name is visualize. We already have all the processed docs. given the entity as Apple, and type org. Run this cell. Again, function object has no attribute called render. Why? Display C. Have I not display? Yeah, display C. CY. Display CY. Yes. Awesome. Yeah, so we can see now wherever Apple is appearing in our corpus, that is in our process docs with the org entity type, those are all getting visualized here. Awesome. That looks pretty good. Okay. And now another application of these named entity recognition is that we sometimes need to show when Apple and Facebook or Apple or Google appears together in a news. That's a very practical use case of analyzing news articles through machine learning. So let's do that. Find sentences where the particular named entity is used alongside other entities of the same type, that is, specific entity type is used a particular number of times. And this is what we are going to find and then show them with spaCy, that is, visualize them with spaCy. But for this implementation, first I need to build a quick method which will return me the length or the count of entity type given a sentence. That is, count of number of times an entity type is occurring in that sentence. So define that function, return count of int type. It will take sentence, in time, return len, int.text, sentence dot if that's all. Let's check that it's working. Let's pick a random statement that we used earlier. So this is a random text. I'm getting the doc object and then applying this return count of n type to get the number of times. And I see 4. And if we look at the sentence, we see Apple, GM, and Facebook. All these three are org. And we also saw the Senate. The Senate was also previously recognized as an org ent type. So the org is appearing with Apple as entity total 4 number of times, and that's the output we get. So this function is working as expected. Now define the next function to visualize these sentences where this condition will be satisfied. Actually, before defining the visualize function for showing sentences where I have a particular entity and particular entity type occurring together, I need to build another function which will extract all those sentences first, and then I will visualize those sentences. So here in the next steps, my method will extract all the sentences from the entire corpus where the sentences will have a particular entity and that will occur with another entity type multiple number of times, and the condition that I am going to set, that is, it should occur at least more than once. So let's define that. As we go along the function, it will be more clear. Return docs of given ent type custom. It will take, as usual, process docs, entity, and ent type. So first, I'm just defining the list which will hold all the sentences that will satisfy the condition. So output sentence equal to, and now I'm going to loop through doc in process docs, for doc in process docs for sentence in doc.sends, and now my condition, and the condition is this entity should present, this end type should be present, and also this method return count of entity type should return more than one. That is, this condition, this entity with this end type presence should be more than one, and only then I will include those sentences. I will consider those sentences as relevant for this purpose. So if entity in ent dot text for the in if ent dot label the time, and my next condition will be return 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 count of entity type. Sentence is PENCE sentence, and end type should return me more than one. Yeah, in that case only include those sentences. Append, and what I'm going to append is sentence den sentence. Okay, why is it showing some syntax error? Let me fix that. Oops, forgot to put the and clause here. Yeah, so both these conditions should be satisfied. Yeah, and now I can just return it. Return output sentences. Awesome. And let's check this method that it's working. So let's do it like this. So what I'm doing here is just invoking these return docs of given end type with process docs, and my entity is Apple, entity type org, and let's run this and print return me the 16. That means there are 16 sentences out of 100 which has Apple and org, and both Apple and org appears more than one. That is this condition. So now my job is to visualize only these 16 sentences which satisfies this condition. And for that, let's define another function. Visualize time. Actually, I'm just going to name it visualize conditional sentences. And why conditional? Because these 16 sentences matched these two conditions. Because I do not want to visualize the entire corpus. I want to visualize based on the entities and entity types that I'm interested in, and also when they occur with some other entity type more than one. And here in this visualization, I'm going to use spaCy, and spaCy allows for some configuration in the way that you want to control the colors, the way they are presented. And for that, I have these two variables defined, colors. Important thing to note here, colors here for the org entity type, it will be a linear gradient. That's how they will be presented. Linear gradient with 90-degree and then these two colors. And then you have to define another variable options where you have to pass ends, pass the entity type that you are interested in, and colors variable will take this color definition. And then the regular stuff. Now for sentence, in sentences, display C dot render, you have to pass sentence and style will be and options equal to options. Cool. Now just execute the method. What was my method here? Pass it, output sentences. I'm just taking output sentences. I'm not taking all the corpus, just the 16 sentences array. And my entity type will be, actually I do not need, yep, that's it. Now let's just run this cell. Let's first zoom out a little bit. Yeah. Cool. So that's how the I'm just visualizing these 16 sentences. Yeah, so the last step was rather easy. All right, that pretty much wraps up this video. If you have liked this one, smash the like button and also do subscribe, because I'm going to do many interesting NLP projects over the coming days and weeks. So see you in the next one. Thank you very much for watching.